All right, so in this recording, we are beginning our unit or lesson section on the double angle identities. But first, we want to make sure, can you evaluate the cosine of 17 pi over 12? Now, normally, if we had to evaluate the cosine or the sine or the tangent, cotangent, secant, or cosecant of an angle, and we were expecting you to do this without a calculator, well, the angle I would give you would have a denominator, when it's reduced, would have a denominator of 1, meaning 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, etc., or negative, or a denominator of 2. 1 pi over 2 is at the top. 3 pi over 2 is at the bottom, then continue, right? 5 pi over 2, 7 pi over 2, and so on. Denominator of 3, 4, or 6 reduced. Because denominators of 6 are 30-degree increments. We like those. Denominators of 3 are also 30-degree increments, but they're also 60-degree increments, so they reduce a little bit more. Or they reduce. Sorry. And then the angles over 4 are increments of 45 degrees, and we like those as well. But, so for example, 2 pi over 3, yeah, that's got the right denominator. If we wanted to find the cosine of that, what is that equal to? I could just, in my head, picture the unit circle. 2 pi over 3, I'm going to find out where that is, right? Pi over 3, tall and skinny like a tree. Those are the ones close to the y-axis. That's 1 pi over 3, 2. That's 3 pi over 3, which is pi, 4, 5, 6 pi over 3 is 2 pi. 2 pi over 3 is right here, okay? Left and then up. So what's the ordered pair? The ordered pairs are what we did to help us out. We went left 1/2 a little bit, and then up, positive, root 3 over 2. The x value is going to give us our cosine, negative 1/2, and the y value, root 3 over 2, gives us our sine. So what's the answer to this question? If we had to evaluate cosine of 2 pi over 3, it would equal the negative 1 over 2. All right, sorry it's a little squished over here, but that was like a quick little throwback, way back. But now we have to do this guy. Where the heck is 17 pi over 12? It isn't one of those angles. It's already reduced, but the denominator is 12 instead of being a 4, a 6, or a 3. We only know, or 2 or 1. We only know those by heart because they're on the unit circle, or by heart where we kind of figure it out and remember what the unit circle looks like. If I wanted to find where 17 pi over 12 is, I could count by pi over 12s, but you know, if that's 0 pi over 12, then that would be 12 pi over 12. That would be 6 pi over 12. That would be 3 pi over 12 in the middle, right? 12 pi over 12, 6 pi over 12, 3 pi over 12, 0 pi over 12. Then that would be 1 and 2 pi over 12. That's 3, 4, and 5. 6, 7, 8. Not, or 8, and then 9. Sorry. 10. Can I count right? 6, 7, 8, 9, 10, 11, 12. There we go. All right, then we have 13, 14, 15 in the middle, 16, 17, 18 at the bottom, 19, 20, 21 in the middle, 22, 23, 24 pi over 12. And that still makes sense. It's 2 pi. We did this way back, like before lesson 6, where I had you make circles counting by everything, right? But 17 pi over 12 is over here. That's not something we know the ordered pair for. So we are going to use angle sum identities. We're going to find other angles that are on the unit circle and add to give us 17 pi over 12. So then we can use an angle sum identity. You could use a difference. We're going to use a sum. We're going to use the angle sum identity from lesson 19, cosine of alpha plus beta. We have a formula for that as long as we figure out what alpha and beta are. So can any of you guys tell me the formula or identity that we would use for cosine of alpha plus beta?
I figured it out. I'm good, Miss Thomas.
All right, Aiden.
Have a good day.
All right, finish the rest of the homework though.
Oh yeah. You saw that I turned in all my missing work.
You
right?
saw, I wrote you a nice message.
I didn't see it, but
Well, look for it. It's all caps lock and smiley faces because I was happy. All right?
Okay.
Get your work
Thanks.
done.
Have a
See you
good day.
soon. You too. It's cosine. Starts off with cosine of something times something plus or minus.
The I'm sorry. What was the loop thing called again? I'm sorry.
Oh, but that was the first thing I had you write in the beginning. If you copied the whole lesson intro, do you have on the top? I labeled it for you. Did you copy that part? And you draw the symbol with an arrow? And I was like, oh, guys, what's this called? And what's this called? Did you copy that part of it down or no?
I don't think so.
Oh, see, this is why you guys got to write everything down. I give you golden nuggets all the time. What's it called? I just wrote it. Make sure you write it down now.
Alpha.
Yes, so cosine alpha, then what?
Plus or minus.
Not
theta?
yet. It's times something first.
Oh, times theta.
That's not the formula. The identity at the beginning of the lesson 19, the lesson intro, is cosine alpha times cosine beta. Now, the formula said plus or minus. So plus is what we're doing. Minus, it could also have a formula. If it's plus, this had a minus plus sign on it. So that means we're going to use minus. If this was minus, then this would be plus, okay? But we're not doing that. We're doing plus, so this part is minus. Minus, do you know what goes after this? Next will be sine alpha.
Sine alpha.
Yeah, then?
And then sine theta.
Beta. Right? That's a B, like a B for beta. So alpha, bet. The first two letters in the alphabet. So alpha, beta. All right. Now, we figured out what alpha and beta need to be, right? So we can do that on the side. Alpha plus beta need to be angles on the unit circle that we know and we can find. And when we add them, I want them to equal 17 pi over 12. But that's pretty hard to figure out in your head. Even the smartest person needs to kind of stop for a minute and do a little side thought or side work. So I gave you guys a big hint and I said, make alpha pi over 4 and you will always have a good time figuring out the rest of it. So alpha is going to be pi over 4. Now, before I even figure out beta, I could even clean this up then. That means I'm doing cosine of pi over 4 plus something equals cosine of pi over 4 times cosine of something minus sine of pi over 4 times sine of something. I could put parentheses. It's not super necessary, but some people prefer it. So we could do that if we wanted. You could put it around the alphas and the betas as well. Now, that's this part. There's that. There's that. We still need to figure out what beta is equal to. So here's the thing. Alpha, if that's pi over 4, beta is what you're going to add to pi over 4 to get 17 pi over 12. Why 17 pi over 12? Because that's the angle I'm asking you about in the question. Now, if I want to figure out beta, right now it's a big question mark. I don't know. I need to make sure all of these numbers have a common denominator first. So how can I find a common denominator for pi over 4 and 17 pi over 12? What would be my least common denominator?
Three.
Not the smallest. You're thinking of what number we're going to use. What number will the denominator for everything be when all is said and done?
4.
It won't be 4 because you can't make things smaller. I always remind you guys, when we say least common denominator, everyone focuses on the part of the word least. And they think in like foreign language class, it's almost like a false cognate where it sounds like it means something, but it means something else. The least common denominator is usually a bigger number, and then the greatest common factor is usually a small number. So it's backwards. So what number will be, if you had to add pi over 4 and pi over 12, what would be the common denominator? It's still the least common denominator, but most people just say common. So what would you make the common denominator between the 4 and the 12? The least common denominator for this, common denom, will be 12. How do I make this have a 12 in the bottom. What do I need to multiply on top and bottom by?
3.
Yes. So you're going to multiply by 3 and by 3. Good. That makes that now a 3 pi over 12 plus something pi over 12 has to equal 17 pi over 12. So we got to figure out beta still. That's what's missing. Beta and beta and beta. So what do I need to add? 3 pi over 12 plus what is equal to 17 pi over 12? What's my mystery little spot going to be?
14 pi over 12.
Excellent. 14 pi over 12. So beta, big mystery beta, as long as I made that one a pi over 4, is going to be 14 pi over 12. But where's 14 pi over 12 on our regular unit circle? We said we needed it to have a denominator of 6, 3, 4, 2, or 1. That's 12. Well, can you reduce that for me?
Seven pi over 6.
Perfect. So 7 pi over 6 is on the unit circle. Okay. And that is beta. It's better to look at it that way. So if you had to reverse this and do it all over again, if I gave you, what's pi over 4 plus 7 pi over 6? You would have done times 3 times 3. You would have done times 2 times 2. Then you have 3 pi over 12 plus 14 pi over 12. And that would give you 17 pi over 12. Bing, 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 bing. That's why alpha could be pi over 4 and beta could be 7 pi over 6. Now we're happy because there are two angles that are on the unit circle and that I can figure out the answers to. So instead of doing the work for this in some magical way, all I need to do is apply this formula and just deal with the right-hand side of my equal sign. Everywhere I have a beta, I'm filling in 7 pi over 6 because I'm following the formula from the angle, sum, and difference identities. So everywhere I have a beta, I fill in 7 pi over 6. That's all highlighted in blue. The yellow alpha is pi over 4 because that was a trick I gave you to make your life easier. You'll always let alpha equal pi over 4. Pi over 4 is actually the same as 3 pi over 12. Really, all of these could be written over 12. And what I wanted to do, and maybe I'll do it at the end of this video, but I wanted to make you guys like a cheat circle. And I'm going to make everything over 12 on it. And what we could do is we can figure out what all of the angles are over 12 and write the reduced one next to it. And we could even ahead of time figure out what adds or subtracts to give us with the pi over 4 to give us the new pi over 12 angle, you know? So we can make that little cheat thing either at the end of this video or in another one, we'll see. So I'm filling in my beta, 7 pi over 6. And now how do I figure out the sine or cosine of something? How do I figure out the sine or cosine of something? What do we need to do? Like, I keep talking about this unit circle. What the heck am I babbling about? How do I get the cosine of something?
You have to figure out the I forgot how to how to explain what it's called. I'm sorry.
It's okay. Well, like, give me an example. Do you know what the answer is for the cosine of pi over 4?
Yeah, for cosine pi over 4 is radical 2 over 2.
Good. So basically, you're looking for the x value of the ordered pair on the unit circle for that angle. And that was radical 2 over 2. Radical 2 over 2. That is what cosine of pi over 4 is equal to. Now, times that minus that times that. So to get the cosine, that was the x value of the ordered pair. What's the x value of the ordered pair for 7 pi over 6?
Negative radical 3 over 2.
Good. So that ordered pair right there, just throwing me a little arrow, negative radical 3 over 2. So that negative radical 3 over 2. Beautiful. But now I need the y values for both those spots because that's how we get sine. So what's the sine of pi over 4?
Radical 2 over 2.
Radical 2 over 2. Yep. Sorry, I'm just grabbing all these different colors. That's going to be that number right there. So that was radical 2 over 2. I'm showing it all, but obviously there's certain steps you don't necessarily have to, show and write because like this work you could show. You might not have to draw the picture, or maybe you like to. It's all good. So what about the sine of 7 pi over 6? What's the y value over there at 7 pi over 6?
Negative 1/2.
Negative 1/2. Good. So now do you kind of see better how that's going to work out? It's just like guided example 1 and 2. Probably more specifically number 2, because guided example 1 I used degrees, which maybe makes things seem easier. But guided example 2 we used radians. But this is how you would do it on a bigger problem. Now we just said that those add up, and that gives us that 17 pi over 12, which is what we were trying to figure out the answer to. So we're a little closer. This 17 pi over 12 mystery guy over here, we didn't know, what that ordered pair is. We can't just get the x value, so we follow this rule. So now, can you simplify a little bit for me and tell me, what's the square root of 2 times the negative square root of 3 going to equal?
I was going to ask if we multiply them together now.
Yeah.
Okay, so would it be negative 6?
Well, negative...
negative radical 6.
Good.
Over 4.
Nice. And what about on this side?
Negative radical 2 over 4.
Good. Now, I'm just going to, since they already have a common denominator, I'm just going to kind of, bloop, bring it a little bit more together, okay? So, over 4 for everybody. And what could I write across in my numerator? We're just going to write everything across.
Oh, just negative 6 minus negative radical 6 minus negative.
Minus negative?
2.
I think we could do a little better than that. Instead of minus negative, we're going to write
radical.
What's minus and negative really mean?
To add.
Right, so we'll just write plus. You know what I mean?
Mm-hmm.
So there you go. Final answer is negative radical 6 plus, negative radical 6 plus radical 2 all over 4. So that's what the cosine of that angle is equal to. Is that so terrible? I think you guys were just getting inside your own heads a bit and confusing yourself. But hopefully that helps you with that, okay? That's the final answer. Final answer. And then the one thing I am going to do is I will, in a next video, oops, highlighter through it. I'm going to make the cheat circle, handy dandy cheat circle. And you guys are more than welcome to use that if you'd like. There would even be like another cheat circle when we get to half angle identities that would involve denominators with 4. So that could be interesting. But if you got this right, or if you at least understand it now and you think like, okay, I get it now, I think I could handle doing another example like this. I could do something like the sine of 19 pi over 12, right? Maybe that will be the next one I give you guys, like next class or something. Then you thumbs up, and if you don't think you can do it yet, thumbs down, but we'll get there, okay? So that's the end of this recording.